Here on Earth Unplugged, we've filmed some incredible flying animals, from giant golden eagles right down to tiny hummingbirds.
And one of the most difficult shoots we've had to do is filming dragonflies in the wild. But when we heard that some robotic engineers in Stuttgart had produced flying robots of these creatures, we had to take a look.
So we're here with Dr. Henry Frunzek, who's done some incredibly lifelike animals here. How and why did you start this?
So we started this years ago because we thought, as an engineers in the automation business, it makes sense to look into nature for inspirations. The smart bird was invented 3 years ago when we learned from nature how a bird is flying. We decoded the bird flight finally, but the role model is a seagull, and all the capabilities of the bird are inside that robot.
And is this just a proof of concept? Is it just because you wanted to replicate a bird, or has this got applications in other areas?
No, it's not about developing drones or flying robots. No, it's a technological era. This is a platform for us where we have technology inside that bird, which is very useful and helpful for our business. For example, energy efficiency, lightweight design, functional integration to keep it in a small body, the communication between controls and that complex system in the air. All this we need in our daily business, solving problems at our customer base.
Wow.
It's having a good time.
How similar is it to birds? Because most of their flight feathers, they have what's called remiges on their wings, which is where they get most of their power, and then rectrices on their tail feathers, which sort of guide them around a lot of the time.
Yes.
Is that what's going on here as well?
We have capabilities inside that we have not only the flapping mechanism, but also the twisting, the roaring, and that gave us this high ratio of efficiency. This is the twisting at the right moment, when the amplitude, the frequency and the twisting angle, that makes it the small frame of control processes, and that's very, very difficult to reach.
Not only have you got this amazing smart bird, but you've also got these incredible dragonflies here.
Yes.
I mean, can you talk us through what's going on?
With these capabilities of the real dragonfly, our flying robot is able to hover like a helicopter, gliding. So everything is on board inside this body. This dragonfly is printed with a 3D printer.
Oh, that's cool.
Every part here is printed. It's coming out of plastic powder.
So, Dr. Frunzek, how difficult are these robots to fly?
So we are using this smartphone, and we can maneuver this. You see here.
Oh, that's cool.
Move it.
Dragonflies often have what's called a pterostigma, which is a little sort of slightly heavier part of the wing just at the end, which just sort of slightly solidifies it and stops it resonating in high winds. But I imagine for you that might be a complexity you don't necessarily need when you've got nice metal rods going through or things like that.
We don't want to copy nature. The dragonfly should not be copied. But the inspiration coming out of this system that nature developed, this is really worth to think about it.
Absolutely. Dr. Fronczak, thanks so much for having us today. It's been an absolute pleasure coming to Festo and seeing these guys at work.
I think it's been just an incredible slow-mo shoot. Having filmed the real thing and robots, it's just both are equally as cool.
It's nice to do it indoors, isn't it?
Well, we hope you guys have enjoyed today. We've had an absolutely awesome day filming robots instead of real animals, and it's just been incredible.
Absolutely, and if you like what you saw as well, do subscribe to the channel for more amazing science videos. And if you want to see more of this little guy in action, do click on him.
And if you want to see more of Smartbird, click on him before he takes off.
See you next time.